I think when we look back on all of this, the nodes, the cables, the endless drag and drop, like 20 years from now, we'll probably laugh. It'll seem quaint, the idea of spending hours building workflows by hand, connecting all these virtual objects on a screen.
Yeah, it'll be a relic, right? Like floppy disks or dial-up internet.
Yeah, exactly. But you know what won't be funny?
What's that?
The results. The breakthroughs and the multi-billion-dollar empires that will be built by those who put in the time, by those who persevere through the noise and just keep building flows. Those that are able to always see the bigger picture, even when there's nothing hanging on the wall. And those that are always ready to relentlessly push through every blank canvas that they see. Because you see what's happening now, this whole new alliance that we as humans are building with artificial intelligence, it's not just going to change how we work. It's fundamentally going to change us and all that we are. And it's going to change and set a new standard for all that is possible.
That's deep.
Yeah, something like that.
All right, enough movie stuff, let's get to work. Welcome to the only masterclass on n8n that you need in order to go from zero to hero. This is not just another tutorial or example or whatever surface level stuff you're used to watching. This is going to be a node by node masterclass in designing and developing node-based orchestrations, where agents, raw models, and third-party services come together. And this is where you orchestrate the best in AI visually. In this masterclass, we will be looking at working with popular visual platforms that allow us to achieve very complex and powerful things using nodes and drag and drop canvases to structure and sequence our final APIs that will then enable our agentic employees and orchestrated automations to perform long-running tasks and assignments. Here's what you'll learn in this masterclass: how to use specialized agents inside orchestrated automations, how to dynamically pass agent outputs to other agent inputs, how to generate images and media on the fly and work with both hosted CDN URLs and raw base64 data, how to connect raw models, APIs, and third-party tools inside of seamless pipelines, and how to design, debug, and scale workflows that actually run in the real world. And above all, you will learn how to think like an organized systems builder. So let's begin. Let's start by connecting a webhook. And before we do that, let's go ahead and name our flow. We can also go ahead and add some tags to it. Let's click on Add First Step and type in Webhook. When we first instantiate the webhook, the first thing we'll want to do is set up a path name for it. So we'll choose something like Generate New Multimedia Content Assignment. We can also rename our webhook node to something more descriptive. Once we have the URL, We can bring it into something like Postman so that we can actually trigger an API call to this webhook. So here we'll set up a new fresh item inside of Postman. And remember, you can use anything that can send an API call. We will leave out things like authorization, but you can easily set that up if you need it. The body JSON for this API endpoint will be found in the GitHub gist. So let's go ahead and dial in a different prompt that we want to use as a test prompt inside of the assignment while we are developing it. Our core payload will consist of a main prompt that serves as the everything for the user, and also some additional information. And I will come back into n8n, I will start the listener, and then we will send in a request. And here we hit a 404 because we forgot to do one critical thing inside the n8n webhook. Make sure to set your HTTP method to post. We'll start listening again and call the webhook from Postman one more time. And here we see a 200 success and the message that the workflow was started. All right, let's keep it going. Click on the little plus. And let's bring in an HTTP node. Inside of here, we're going to place a flowise agent. This canvas is available inside of the Academy and the Vault. You can use any agent here from another framework, from Flowise or LangFlow, a raw LangChain agent. In Flowise, we're going to grab the curl. And let's paste our base curl here. Click import. And all of our core details are now filled out. Let's go ahead and rename this HTTP request node to be something more descriptive. Name it something like draft first. The data that will be coming from the webhook will be sent in directly into the HTTP node. Since we will be bringing in a lot of our initial data from my production workflow for this, I will go ahead and rename the webhook back to webhook. That is what I called it in my original flow. But you can name the webhook whatever you want. Let's scroll down to the body inside of the HTTP node. We will convert the body parameter question value to a dynamic expression-based value. And let's paste in our prompt number 1, which is coming from the GitHub gist. This prompt basically instructs the agent to do research, to do writing, and to do an overall kind of content production assignment. And we're passing in the main request from the user and the additional instructions. Let's execute our node. We'll speed things up here just to keep us going. And there we have it. Our first response from the agent is now available to us to use in further nodes. And this is what we will consider as our first draft for this orchestrated automation. Okay, so let's go and take a look at our second agent. I'll go ahead and copy over the initial HTTP node. And then we can connect the output of node 1 to the output of node 2. Let's go ahead and rename the node to something more descriptive. There we go. And now let's go ahead and change out the prompt. Here we will delete the prompt from agent 1 and put in our agent 2 prompt, which you will find in the GitHub gist. Let's quickly take a look at what we're doing here. We're adding a couple of dynamic parameters in a very similar way as we did inside of agent 1 node. We're still passing in our initial main prompt from user, and now we're also adding the first draft that was generated by agent 1, and we'll use the .remove markdown parameter on it. Let's go ahead and run this agent node. There we go. Here's our output. So now we have a second draft that was produced from the output of the first agent. Excellent. Let's go ahead and tidy up our workflow a little bit. I'll paste in a sticky note from our production flow here, and we'll place it into the webhook space. Let's expand and add some space in between our other nodes so that we can also place them into sticky note containers. Excellent. We'll add this first agent, copywriting draft sticky note, and surround our node 1 with it. Let's do the same for the second agent. There we go. Now we have our 3-node workflow. Let's continue. All right, let's do it. So we will translate our copy into image prompts. And for this, we will use an OpenAI assistant. It is great to use OpenAI assistants for very simple, small, and focused tasks like this. Let's bring in an OpenAI assistant resource and rename our node to something more descriptive. Excellent. Let's select our key. The resource we'll be calling is of type assistant, and we will be messaging an assistant. Now let's go ahead and select one of our available assistants. Here you can use a tool agent or an agent from another framework or anything that can process text-based data and has some basic agentic LLM functionality. We'll set this to use thread ID, as we do not need this to be running in long persistent memory. Let's change our prompt to be an expression. And here we're going to paste in our third prompt, and this you will also find in the GitHub gist. And this prompt basically dictates a very specific schema that needs to be produced by this assistant and all of the different individual image prompts that need to be populated into this schema. You can see that we're specifically asking for a JSON object with different types of key names in it. And then we will pass in the assignment content and also the brand design tokens so that the assistant knows how to better prepare the image prompts. For this assistant, we will not be needing any tools, as we simply need a quick writing operation done. Let's go ahead and run it. So what's happening here is the assistant is reading the content that was produced by our copywriting agents and now doing its best to match certain visual elements to what was produced in that text. So that if we want to do articles, social media posts, or any other type of multimedia type of assignments, we will have very similar looking images that do support the narrative produced in the copy. There's our output, and if we examine it, we can see that it is a JSON object, and we have a bunch of different keys in it, just like what we requested. And this will make it easier for us now to work with the multimedia generative nodes, as we will be able to pluck and extract the exact prompts that we need. All right, let's go ahead and set up our media pipeline. So first, I'll put this note here, and this is what will allow us to see that we are now doing media generation and not text production. Let's go ahead and add some additional stickies here, just so that we can stay really organized, and this can sometimes be helpful when you're initially laying flows out and don't want to get lost or kind of miss where you're supposed to go next. So I'll add these notes here to further delineate where each node is heading. All right, we're going to work with FAL.AI, which is a developer media cloud. Let's bring in our first model, which will be Flux Pro version 1.1 Ultra. You will find the full curl inside of the Gist GitHub, but you can also grab it from FAL. Let's go ahead and copy over a node. I will grab one of the template nodes from the production flow for this, but it is an HTTP node, just like the text agent nodes. And let's specify which model we will be using here, again, to stay organized and know what we have done and what we still need to get to. Great, let's save up and open up our node settings viewer. Let's go ahead and make sure that we have the right path inside of the URL. And these always will correspond to the path names that are visible in the top left corner of the different FAL.AI models. Okay, here we see our already pre-filled JSON body schema. But let's go ahead and set it up from scratch. So we can open up our curlies. Let's target JSON object from the previous node. Let's say dot output. Then we want to go ahead and do dot parse JSON. And then we can select the prompt that we need. So now you could see how only one prompt is brought into our main prompt that we're sending to FAL.AI. The rest of the parameters can stay the same. Let's go ahead and run the node. Excellent. There is our first generated image. Let's do the second image from another model in the next section. All right, let's continue with the next node. This time we will be working with Minimax's Image 1 model. Let's go ahead and grab the code we need from FAL dashboard. Copy over your curl. And back in n8n, I will go ahead and copy over the node from production. But again, we're just setting up a new HTTP node. Let's connect the output of the first image to the input of the second image node. Same schema applies. Let's go ahead and open it up. And now we could see that because I brought it in from another flow and the node there is named something a little bit different. So I will go ahead and rename and target the correct node to get our output from. And you could see we're adding a couple of additional operators into the expression. Although these are more cosmetic because it's unlikely that our assistant would be outputting any sort of a space or special characters or other things that could be problematic. But we'll go ahead and employ those anyways. All right, let's run it. Minimax model does take longer to produce the image. So that is something to keep in mind. If you want to build a very low latency pipeline, then Minimax model may not be what you need. Excellent. Moving on to the next node. Okay, next let's bring in Imagen 3. We'll change the label here to reflect that we will only be outputting one image from this model. Then back at FAL.AI, search for Imagen 3 and grab your curl if you're following along from scratch, or grab the fully implemented curl from the gist. Excellent. Let's set this node up as well. As you can see, it's all copy paste because we are using the same provider and just switching out the different models. Let's go ahead and target the correct node, and the same operators form the same expression. Let's run it. Perfect. We have our link. Let's continue. Next model is called Recraft. And this is version 3, and we're using the text to image endpoint. Again, grabbing our code that we need. And again, modifying the body JSON to make sure that we are passing our data correctly. Target the node, see the value go green, and apply the operators. Excellent. Run it. Perfect. Have our URL. Let's continue on. Bringing in our next node, which will be getting an image from the HiDream model. HiDream I1 full. We already know the drill. Grab our code if we need it, or copy paste it from the gist. And let's bring it into our HTTP node. Going to add one more sticky so that we can stay nice and organized. One more time, we're going to check to make sure that our node has all the correct settings and that no data is undefined. We will change the name of the node that we're getting the prompt from, just like we did with all the other nodes before. And make sure all of our other settings are correct. Let's run it. Excellent. Now we've got our link here, and let's move on to our final image node, which will be using the new GPT Image 1 model from OpenAI. One thing that will be fundamentally different about this node is that we can only receive the results from this model as a base 64 object. So we won't be working with a hosted URL here, but instead We will be taking advantage of n8n's utility nodes to process and correctly save our base 64 data. So again, I'm copying over my node from the production flow, but you can easily and quickly set up your settings. In order to get all the information about GPT Image 1, visit OpenAI's documentation, and every parameter, it will be neatly described there. We can see that we can send in things like what type of background, the model choice, whether we want to have moderation enabled, the quantity of images, and most importantly, the output format. So we get to decide which format the data could be in. But since we are using GPT Image 1, we again will be processing base 64 data. So let's connect our output from the HiDream node and into GPT Image 1 node. And again, to get our prompt, we're going to need to make sure that we're targeting the right node that's coming from earlier in the flow. Excellent. There's our prompt, and we can go through the form data and make sure that everything else is correct. There you could see that we're using a dynamic expression to set a number, to set an integer, and so that we don't have to send in a string. And all of the other parameters are coming from the OpenAI documentation. Okay, that looks to be correct. So let's go ahead and fire it in. One thing to note again, that just like with Minimax Image 1 model, I've noticed that GPT-1 Image 1 also takes quite a bit to produce the final results. So if you're going after quality and definitely want to be using this model, then expect there to be some delay as to when you get the results. And if you want something fast, you've seen how some of the other models were almost instant in just a couple of seconds. I'll go ahead and speed up the tape to keep us going. There we go. And now we see that we have a binary object that we can either show here or download to preview. And it is a 3.3 megabyte high quality and high resolution image. And there we see that there's a small delay because the base 64 JSON object is quite large as far as character count is concerned. Excellent, let's save up. All right, the next node that we're going to work with is called the set node. We're going to set this image data into its own dedicated node. Go ahead, click the plus and search for set and edit fields, and set node is what we need. Let's give it a more descriptive name. Okay, next, let's switch the mode from manual mapping to JSON. Go ahead and open it up. We're going to set two keys, or we're going to create two keys and then set two values into them. The first one is data. Going to step out for a second and change it to dynamic expression so that we can use dynamic values from previous nodes. Okay, one more time. Open it up. Inside of the data key, we will go ahead and open up our curlies. Target JSON dot base64 JSON. Do you see how we need to add that additional 0 value so that the index can be recognized correctly? And the next field, we will call it file name. And into here, we will set the file name of the generated image. And here's how we're going to construct our dynamic string for this. Let's open up our quotes, type in img, and then dash, plus money sign, and we're going to use execution ID dot ID plus, open up quotes, dash, another plus, and then we're going to target item index. You can see just how large this text representation of our image is. And then we could see that the file name will now be dynamically specified here. Let's run it. And there's our set data. All right, great. Moving on. All right, let's do our next node. So right now our data is a base64 string, but we actually need it to be a file. So let's go ahead and grab the convert to file node. And we're going to use the move base64 string to file action. Let's rename this node to reflect what we're doing. Okay, the base64 input field, if we look on the left, we see that it is called data, and that is what we will put there. And we will also specify data as the output field name. And then we will add another option and put in a file name. Convert that to dynamic. And you could just drag and drop the file name chip, but we will go ahead and type it out. Excellent. Run it. And there is our binary file now, which we can upload to an AWS S3 bucket. Let's go ahead and do that. Grab the AWS S3 node. And the action that we want to use is upload file. Again, renaming it to reflect what we're doing. Awesome. Select your key, file operation, upload, specify your bucket name, And now let's go ahead and set our file name here. Let's find the node that we need and target the item, JSON, and select file name. And notice here we're also going to say .png and hard code the MIME type to the end of the file. And we can see that it is a PNG image in our binary object on the left. Okay, let's run it. And there we go. AWS S3 node will output a success message if the file is uploaded successfully. All right, let's keep it going. In our next node, we will go ahead and combine a base URL with the dynamically generated path file name that we created, and we will set that into an edit fields and set node so that we can have it for downstream use. So let's grab our edit fields set node, and let's go ahead and change it out to JSON. And let's also go ahead and rename it to something more descriptive, as we have been doing for all the other nodes. Now let's delete the placeholder JSON, and I will paste in the JSON that you can find in the GitHub gist. And what is happening here, as you could see, we have a key name called AWS S3 uploaded file URL. And then we are hard coding in the name of our Cloudflare based base URL, and then adding dynamically the file name from our set data from incoming node for downstream use node. And we can see how in the preview, in the result, we get a fully constructed URL. Let's run it. And there we have our new URL. This we can now use just like we have been doing with the FAL.AI cloud links. All right, let's go ahead now and work on our asset compiling part of the pipeline. So we are all done with the text production. We're also done with the media generation. So now it's time we compile these things into social posts and basically everything else that we need. What I'll go ahead and do and drag around a couple more sticky notes to make it super clear as to where we are and what we're doing. Let's zoom in. Let's rename this sticky to something more descriptive, as again, we've been doing all along. This part will be known as asset compiling and pre-publication stage. Excellent. There we have our planning done on the stickies. So let's go ahead and do our first node. We will use an OpenAI assistant again to initially provide us with all the different metadata and formatting that we will be using in the Banner Bear service. And before we do everything node by node, for this part, let's actually go ahead and lay out all of our nodes first. So we'll have the code node after that. And then after that, we will need another edit fields set node. Then after that, let's bring in one Banner Bear node. Choose the action to be create image. Okay, continuing on, we will use a wait node because we will need to wait for the image to be generated by Banner Bear before retrieving it. And out of the wait node, we will use another Banner Bear node. And this time, we will be getting an image. Great, moving along. We will copy over the first Banner Bear node because we will do two different actions through them, one landscape image and one square image. So one more create image node. Again, copy over the wait node, and that will go right after the create image. And one more time, let's copy over the get image and hook that up to the wait node. Okay, do now an HTTP request node. And let's also bring in another code node. Then one more HTTP request node. And yet another code node. Continuing on. So let's do our metadata OpenAI assistant now. Click on the node. Again, rename it. Excellent. Set your key. Select our resource, which again is of type assistant. We're going to message an assistant and then select an assistant from your OpenAI assistant portfolio. Again, this node here can be substituted for an agent or even a simple LLM call that can come from just about anywhere. You don't have to use an OpenAI assistant here. Okay, we will define the source for prompt as defined below, and we will use thread ID without a memory connector. For our prompt, I will bring in yet another copy-paste operation from the GitHub gist, and you can review this slightly longer prompt afterwards, but basically we're defining a task objective for this assistant. We are setting some dynamic data, then we are sending in an example of a JSON schema that we needed to fill out with the different brand token values that have been provided earlier. And we're calling all these brand tokens dynamically under the brand token heading. And we also have item text copy for title and read time. So this is what the assistant is expected to review and produce a dynamic value of approximately how long it would take to read the full copy that has been generated. So once again, I'll remap that to the correct name of the node, and now all of our values are green. All right, let's check that everything is indeed correct and fire it in. All right, so let's quickly break down this custom code script that we have. So first, what's the goal here? we want to take a piece of data. Specifically, it is a string of JSON that's inside item.json.output. And then we actually want to turn it into a real JavaScript object so that we can use it downstream in our workflow. So here's how it works. Step 1, for every item that comes through, we run this function. We take the output property, which is just a string of JSON, and we use a JSON.parse to convert it into a real object. And step 2, we use the spread operator to merge all of those new fields from the parsed object directly into item.json. This way, all the properties from our parsed JSON are now accessible just like any other field in n8n. And finally, we return the updated item, and n8n passes it along to the next node in your workflow. So, in plain English, the script takes a chunk of JSON text, turns it into real data, and merges it into your existing item so you can use those values anywhere else in your automation. All right, continuing on. Let's go to our set node here, and into here we will essentially dump what we parsed in the previous node. The content will be set into this node just to keep things nice and tidy, and also allow our signal flow to maintain as much integrity as possible. So here we will use the manual mapping mode, and I'll just drag our output. And the only thing we're going to do is change it into type object. Okay, let's run it. Great. Now we can pull things out dynamically directly out of this node in a bit easier and friendlier way. Okay, let's do our first banner bear node next. All right, click on the banner bear node. And once in our banner bear mode, again, let's quickly give it a name that means something to us. Okay, resources image, create. Then we will select a template. So Banner Bear is a service that allows us to create any type of templates and then dynamically set values into these templates. So let's go ahead now and expose all of the different modifications, or essentially parameters, in this node that are configured and available inside of our Banner Bear template. And we will take a look at the Banner Bear dashboard here in just a second to see how all of this maps to each other. So as you notice, we set all of these values, such as title, author photo, and make note of that as we will see these same values as soon as we look at the Banner Bear dashboard. So here we are in Banner Bear. You will want to make sure you're working on the right template. Click on Edit Template. And on the left here, you will see things called layers. And these layers are exactly what we're setting into the modifications. So however many layers you have here, and whatever you define here, that is what will be used inside of n8n Banner Bear node. Save it. Let's exit. We can also open up the API console and see the JSON representation of all of this data. Okay, so now I'm going to pull out the values that we have created into these dynamic objects in earlier nodes and start setting them into the correct slots. So we'll grab the color and assign it to the background color parameter. And then we will go down the list and keep pulling out all the various values that we need in order to produce the branded and fully polished social post image. Depending on how you construct your keys and objects, some of these values may be different, but if you're following along, just grab and pull them from where you can find them. If you have access to this full n8n template, you will also already have all of these values preset into the fields. So I will go ahead and speed up the tape here. When working with the banner bear node, you will notice that there are multiple params that could be set for each main key, so you want to be really careful as to which values you place where. For example, on the background node and on some of the other more color-specific nodes, make sure that in banner bear you check what those values and keys are actually named. So background has background and color, and we could set things into both, but really if you look in banner bear, we only need to set things into the color key and not both. Okay, let's fire it in. And there we go. It is a very fast response, and as you could see, our links are not provided. And that is because the image itself has not been generated yet. And that is why we employ the wait node, so that we can pause our flow, allow banner bear to finish what it needs to do, and then we retrieve the image through the next node. So in the wait node, I'll just rename it to something descriptive. 5 seconds should be fine, but sometimes you may want to play around with it because certain services can take longer to finish their jobs. Excellent. everything just passes through the wait node transparently. So now when we activate and engage our get image node from Bannerbear, we will be able to get URLs for it, just like we were able to do that with FAL.AI Developer Cloud Media Links. So let's open it up. Quickly conform the node to our workflow. And then the only thing that we will need is the actual image ID. And for that, set the type to image, description to get, operation to get. And for the image ID, we will use the UID value from the first node, as that is the image that we want to retrieve. Run it. And there we go. We have multiple image formats that we can now use downstream and serve. And let's keep going. So the next segment within our sequence will be another 3-node Bannerbear setup. And this time we will be working on a square image, a 1:1 and not a 16:9 landscape. So we will use different template here. Let's set up our node, rename. Set up the key, and now select Square Base Template, or whatever it is called in your Bannerbear account. And once again, I will go ahead and first expose all of the different keys and the params that we will be setting data into. There we go. So now let's go ahead and assign all the different values that we need to their corresponding modification layer names. Okay, let's run the node. And the same thing happens. We receive our response, we get a UID, and now we will have to time out the workflow for 5 seconds, and then we will fetch our URL. Okay, we'll just move these nodes a little bit out of the way. And let's go ahead and activate our second get image node from Banner Bear. And once again, pass in the UID, run the node, all right, let's keep going. So the next node we will do will be an HTTP request node again. So we will be sending an API call to a flowise agent. So let's go ahead and rename our node. So we'll be making a post call. And then let's set up our node. Bring in your URL that we will be calling. And we will send our body. The only parameter that we need to truly send in Flowise's case is called question. And for the value, we will make it dynamic. Paste in the prompt, again, found in the gist. And as we've done before, we will simply need to rename the nodes. And just a quick note, this is only happening because I am copying and pasting things from the production flow into this live rebuild. So in your case, when you're pulling these gists, they should already be all correctly referencing the nodes that they have to be. But basically what we're doing, it's a simple directive, and we're passing in both drafts to ensure that this agent has all the context that it needs in order to perform this assignment. We are adding a couple of parameters. We're removing markdown, we're replacing all new line characters, and we're also replacing special characters. Let's send it in. And there we go. We have our results. We can see that there has been a couple of tools that were consulted to produce the correct data for us. And now we are ready for the next node, which is a code node. So let's rename. All right, so let's walk through this short script together as I type it out. So first, I'm gonna start with a return statement, because in n8n's code node, we always want to return an array of items. Now, for each item, I want to clean up the data before I parse it. Sometimes JSON strings can have stray new line characters, and that can really mess up parsing. So I'll remove all new lines from item.json.text, and that will zap all of these new line characters out. And then we're left with a nice clean string to parse. And next, I want to take all those fields from the parsed object and merge them directly into our item.json. So that way, everything is easy to access in the next step of the workflow. And finally, I return the updated item so that n8n can pass it along. So altogether, this script loops through every item, strips out new lines from the JSON string, parses it, merges the new fields in, and returns the updated item. Super useful for cleaning up and unpacking messy API responses or any text really. Let's keep going. Next is another HTTP request node, and we'll name this one to compile generated assets into HTML object for preview. Let's set it up as a post and add in your URL. And once again, this time we will send headers. Do content type, application JSON. And we will also configure our body params. And just as we've done before, only one going to flowise called question. And then let's set our dynamic data that we will be sending to this agent. Okay, I will copy things in from the gist. So what this agent will do is we'll go through a lot of the stuff that was generated previously and then compile it into an HTML object that we can then utilize downstream. All right, and once again, let's make sure that we are mapping the correct dynamic values to their respective nodes so that all of our data is defined. Okay, the JSON structure is set. Now let's grab our banner bear image URLs. Find the correct node and select it. Same with our drafts. Let's map those to Agent 1 and Agent 2. And then also make sure that all of our image nodes are also correctly mapped. All right, there we have it. All of our values are now defined. And we can quickly check that in the preview to make sure that nothing is showing up as undefined. Okay, let's run it. There we go. We now have inside of the text key a fully formatted HTML object. So now let's go ahead and utilize one more code node. And this code node will quickly scan and analyze, or simply the stuff will run through the code And then if any new line characters are found, we will go ahead and convert them. Again, you can find this code in the gist. Okay, let's run it. And there we go. And now use this HTML to preview what our automation has made. All right, let's go ahead and now do the final section. In this section, we will utilize 3 nodes. We will create a full schema of all the stuff that our automation did. Then let's go ahead and also drag the Supabase node. And into Supabase, we will set all of the data that we put into the schema. And then we'll use just one more node. It will be SendGrid. So grab that. And the action that we want is send an email. And this will send a fully formatted, ready to preview email at the end of this automation. Okay. So let's go ahead and open up this set edit fields node and rename it. And this node will capture every single item that will exist as a column in our Supabase data table. Okay, let's also rename the Supabase node. And the same with our SendGrid node. You can use other providers, but I typically work with SendGrid. And of course, you don't have to send this notification email at all. Okay, we will use the manual mapping node. And I'll go ahead and start by dragging the text from our previous node, set it as string, and that is what will be put into the rendered HTML key. We can also quickly preview what this HTML object exactly is doing by going to a free online HTML viewer. So we can go to preview full page and paste in our HTML. And there we see exactly everything that has been produced and put into this HTML object. Great. Everything looks neat and organized, and we even have a slider carousel that displays all of the images that were generated. Looks like the table formatted correctly, so we are ready to go. JSON.text will be going into a Supabase key named rendered_HTML. And before we do anything further, let's go ahead and go into Supabase and create our table. All right, there we are in Supabase. So let's go ahead and type out all of our statements that we need to create this table. So we'll say create table if not exists in the public schema. And we will call it store_completed_agentic_assignment. And then I'll also say live demo masterclass. Great. Open up. And let's start setting our items. So we will need an ID, which will be of type UUID, and it will act as a primary key. And we will also call default to generate random UUID, gen_random_UUID. Next, we will want a created at field, which will be of type timestamp. Okay, we'll make sure that it's not null, and it will default to now. Okay, let's skip a line, add a comment. We'll say foreign key to auth.users. In Supabase, you also have a hidden non-public schema called auth, and that is where your actual users that are authenticated and registered inside of this Supabase instance live. So we'll say user_ID will be of type UUID, and it will references auth.users ID. And on delete, we will cascade. Great. Continuing on. Let's first comment this as post metadata, which will be capturing all of the core asset identifiers. So we have things like title, and that'll be of type text. We also have pre-title of type text and subtitle, again, type text. We also have a description, which we may not use, but we'll create it for now. Then we have author, also a author_photo, and date of type timestamps. Okay, one more line, jump, and now let's create a comment. This is where we're going to do content drafts, all the core copy and all the final stuff that we are going to be publishing. And for that, we have the first draft, which is text. And we have a second draft. And we also have final_text_to publish. Okay, continuing on. Now let's do our images. And here we'll say post_images, and it will be an array. Then we'll also save the image container of type text, which again, we may not use, but we will have it here available to us. Ideally, when you're creating tables, you do not want to be putting anything that absolutely does not need to be there. Okay. Next, we have main landscape image, again of type text. This will store the URL of the main landscape image and the main square image, both of type text. Skip another line. Okay, now let's create the necessary columns for the design tokens. We'll have design_tokens as a as of type JSON-B, which is a JSON object. Okay, then we also have some additional stuff like the read time, the template ID, and the different types of modifications. We'll have read time be of type text. Also a template. And modifications, which is JSON-B. Let's keep going. We have prompts and HTML and our core preview object. So here we'll say image underscore prompts, and that'll be of type text. And the rendered underscore HTML is the object that we previewed in the online viewer. Then let's do tags and keywords and all the SEO information. Okay, there's tags, and it is an array of texts. There's keywords, and it is also an array of text items. SEO underscore metadata, which will be a JSON-B object. And social underscore platforms underscore published underscore on. And that will be an array of texts. Then we have status flags, is underscore published, and that will be of type Boolean for true or false. And we'll have it be not null, and by default it will be false because we're not ready to publish until we review everything. And we also have is underscore approved, which will also be of type Boolean. Then let's do tool outputs. So this will where we're going to store all of the different tool results that were used throughout the automation. Tool underscore outputs, and it will be a JSON-B type. And then let's also do metadata here. You can do JSON-B as well. Okay, let's review everything that we did really quick. We have an ID, we have a created at, we have a user ID foreign key, which will allow us to map the different users in Supabase to the assignments that are created. Then we do title, pre-title, subtitle, description, author, and author photo, and date timestamp. Okay, then we're saving the drafts that were produced, and so on. There we go, quick error. Make sure you have an underscore. Otherwise, it will not, the command here will not be successful. Okay, let's run it. All right, and we encounter an error on line 23. And here we have a syntax error for the post_images line. And that is because we forgot to define the type that this is supposed to be. So let's go ahead and add text, and that will solve the issue. Run it again. And there it is. Success. Our table was created. We can verify this by going to the table editor, and there we see our table, and quickly check the schema that we just dialed in. Yep, looks like everything is there. And in production, you will definitely want to enable and correctly set up all of the row level security. For now, we will not deal with it. All right, now we're back in our set node, and we have our schema defined. We've set what we need to do inside of Supabase. So now, before going straight into the Supabase node in n8n, we will go ahead and again set everything into a predefined schema here. So we'll start with our rendered HTML, and for that we will target json.text. And the next parameter, now you will see them be very familiar. We will just go one by one through every single column that exists in our Supabase table. So next, SEO strategy text. So for this, I'll initially drag this text from the research and compile tags, keywords from flowise agent node. And let's go ahead and hard code in some additional text to be able to delineate what it is that we're setting from each different source. So I'll say results from SEO Agentic Operation. And then let's bring in our object. We will .parse and JSON it and pull out the commentary. So as you could see in the result, we extract the exact piece that we want to use. Then I'll also add an operator for replace all. And let's open up our single curlies. We'll put comma. And then we will replace by nothing. So just a empty set of single curls. I'll add 3 lines here. Let's keep going down the line. So we'll add social tags. Okay, I'll copy paste this in. We will be applying the same operators, but first let's back up to parse.json. Parse JSON, and then pull out our other key, which is as SEO keywords here. I'll add a join operator. And we will join by comma. So single curlies, open up, and comma, and space. Okay, 3 more lines to create the divider. And now let's do the SEO keywords. Again, really quick, removing everything at the end. And now we need to go dot into our SEO keyword values. We'll go SEO keywords. And actually, let me change out the tags. There we go. Quickly swap out the piece of information when you need to. Okay, and we'll apply some additional operators for this one as well. We will join it. There we go. So let's also do our CPC and volume returned information. And as I'm building out these keys and sections, you can see how you can quickly customize these things to do exactly what you need. So if there's additional things that you want to be passing and collecting here, then we just add them in the paragraph. Let's type this out. This is going to be a slightly more challenging expression that we build here, but we'll get to see just how versatile and powerful n8n can be. All right, so let's start with the opening braces and our $. Let's spread them out. We're going to be targeting and pulling from the research, compile, tags, keywords from flowise agent node. So let's put that into our single curlies. Okay, now let's do the data extraction chain. So we'll go item.json.text, then drop into a new line and parse JSON. New line again, and then dot into CPC volume details. Okay, next let's do the transformation with map. So we'll do dot map, item arrow. Then we're gonna open up our backticks. Then in there, I'll type keyword. And then let's put our $sign and dynamically say item.keyword. Okay, comma. Then let's do volume. Same $sign, and we're going to now target item.monthly_search_volume. Next, let's do high CPC. And again, $sign curlies, then item.I_CPO_USD. And then let's also do low CPC. And then finally, also competition. And for that, we'll target item.competitionindex. All right. And then let's complete this with join and closing. We'll say .join, and we'll do by new line. \n. Done. There we see our transformed object here. And all we had to do was just work with some operators to create the perfect data format that we need. All right, let's keep going. The next thing that we're going to set will be the follow-up prompts. So I'll go ahead and drag the follow-up prompts key. Let's do a little bit of operating on it. So .parse JSON, .replace all. And what are we replacing? I'm gonna just quickly grab those square brackets out. So this is kind of like manual deconstruction. And then we'll do another .replace all. And here we'll do the right bracket. So just a bit of a crude way to get some data transformation done. Then we're gonna do one more replace all operator. And we're going to take out the commas and put in new lines instead. Now let's also do that one more time, and we'll remove the double quotes. There we go. Nicely transformed data. All right, let's do the next key, which will be the main square image. Let's type out the key name. And for our value, we will target the retrieve second generated asset node. And we'll use the image URL. And then let's do the main landscape image. And we'll set the image URL from our retrieval of the landscape 16.9 node. Okay, and the next node after that, we'll do the modifications. Let's grab the whole object and set it. And in our operators, we'll add a .to JSON string. Next, let's set the read time value. And before we do that, let's go ahead and just expand out a bunch of slots that we can set into so that we don't have to do that every time. So read time, author, author photo, template, date, keep expanding out the slots. So now let's set all the different images that were generated as individual items. So we have image 6 landscape, image 5 square. Then we have image 4 landscape and image 3 square. And then also image 2 landscape and image 1 landscape. Then from there, we need to set our image prompts. And then we can do second draft and first draft. Then let's do Supabase user auth UUID. Supabase. 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 And then we have the assignment user system prompt. Then let's set our design tokens. And then let's add an array, all post image URLs. Then we have tags, keywords, and things like title, subtitle, pre-title. Then we'll go ahead and ignore type conversion errors, and we will support dot notation. We should always support dot notation. Okay, so going back up and now going to set the values into all of the keys. So find the read time value and slap it in the slot. Set the author. And the photo. And also the ID of the template that was used. And this ID comes specifically from the banner bear values, just because I chose to track that. But you can also track any other type of ID here. Okay, and for the date, we'll grab the date value. And what we will say is .toDateTime, and then .format, so that we can get a pretty looking human readable value, which in our case will just be that 2025-05-31. Now let's do the image values. Let's find our image 6 node. And for that, we've set, there was a couple of nodes that we did into AWS 3, but we find the value and set full AWS 3 bucket object URL. That represents our image 6. Then for image 5, let's find our square, pull in the URL value, and that is what we're storing. So in case you're a beginner and watching this, the actual images are not stored inside of Supabase table. References to those images, wherever they are actually being stored and CDN'd from, that's what we're storing here in the table. Okay, so now let's do image 4 and just go node by node and grab the URLs, since the FAL.AI developer cloud links enable us to just grab the URLs and then utilize them wherever we need. It is also important to note that a lot of times you may not want to use FAL.AI as your CDN provider. So these links here are just for educational and demonstrational purposes, but most likely in a final production setting, we would store these URLs also, or these images inside of our AWS S3 bucket. So pulling in all of our values, we are not adjusting or altering the expressions. Everything stays the same, so it's just more now a mapping exercise. Okay, so for the prompts, let's open it up, convert it to an expression. Okay, and here, let's hard code in our prompt 1 value and then continue that down all the way the list. When we set up our prompt for the image generation assistant or the prompt maker, there is a total of 8 prompts that is being requested. So we will be able to utilize these. We have 6 images and 2 extra bonus prompts. So we can set them again all from the respective node. So I'll go into that node, grab our output, and now since we want to separate them here, I'll say .parse JSON .image1 landscape. So we'll grab it out dynamically here and set it into our mixed value. So let's go down the list and we will just convert and adjust the image path names at the end. There we go. Our image prompts key is now completed with all the different values. So now let's do the rest. So our second draft will come from the second agent's node. Then let's find our first draft. Then let's do our Supabase user auth UUID, which will be coming in our case from the Webhook. So this is what represents a user in a database. In our case, it being Supabase. Supabase. Then let's set the original system or user assignment prompt. And there are 2 values that we're using. So we'll delineate between them by saying original assignment prompt from user. And then additional details. is what we called it when we were initially sending things into the webhook. Now let's go into the webhook and grab those values. Next, let's do the design tokens. So these will pull out of the webhook node. So we can quickly check that our design tokens here in our Supabase instance is of JSON binary, JSON object. So we cannot be sending a string value into that. So what I'll actually go ahead and do is add a new column. We'll call it design underscore tokens underscore text. And here we will be able to set a string or send in a string value from n8n. It is of type text. And it'll default to an empty string rather than a null. Okay, save it. Okay, now back in n8n. Here we'll reflect this to be an object. And I will copy and paste everything and add another slot for us to use. So just like we just did in Supabase, we created it, and then design tokens text is here. So copy that out, and that string will send in as a string, paste it in. So here you see how we're deconstructing that JSON object and just converting it into text. And then in the object version, we will only pass in the object itself. And that is so Supabase doesn't freak out, and we will see in a second how. There we go. It's just an object. Put it in. All right, next let's do the array all post image URLs. So we'll set the value, we'll set the key, to be an array. And let's manually construct an array. Okay, let's grab the next value. All right, let's do the tags node next. So I'll set it to an expression. And let's scroll down, find the one we need, and grab the full JSON object that is in the text key. And then we'll do .parse JSON. And we'll pull out the social platforms tags keywords. And then we'll say .join. And inside the parentheses, we'll open up single quotes and say comma space. Then let's do the keywords. Again, set it to expression, open it up. Let's put the text key again. Once more, we will parse JSON it. And this time we'll pull out the SEO keywords, and we will still operate on it with a join, comma space. Okay, looks like our schema is complete. Let's try it out. There we go. And now we can see that all of the objects that we just set are available for us to use inside of the Supabase node. Okay. Let's work on the Supabase node next. Let's open it up. So our resource will be of type row, and the operation is create. We will want to select the table. Make sure that you're putting things into the correct table. So we'll double check in Supabase. Excellent. And we will say define below for each column. So now under fields to send, we will go ahead and expose in our form all of the different database fields that we have in the table. Okay, now that we have all our fields set, let's start doing the values. So for the ID, this will be coming directly from Supabase. As you might remember, when we created the table, and we can quickly check this in our SQL editor, the ID is being generated randomly every time a new item gets created. And that we can see here, it's of type UUID, and we have a gen_random_UUID. So we will not need to be filling that out from n8n. That value will be automatically created for us when a row will be inserted into that table. So let's do our created at, and we'll open up our dynamic curlies, and we will simply say now. Then the user ID that is coming from our auth table inside of Supabase, that is something that we've already sent in from the webhook. So let's go ahead and pull it out from the webhook node and set it here. And since we want to be attributing this work to a specific user, in our Supabase schema, we have a protected hidden auth schema, and that is where our core user table lives. So every time that a user registers within our Supabase instance, the row is automatically created in this table. So that is where the ID value is coming from. And there are two unique IDs. So one that exists for the user, and then one that will be automatically generated for this assignment or this database transaction that we are processing now into Supabase. Okay, let's do our next field. And it looks like we did not set it into our original set node. So let's go back to this node really quick and add it. There we go. And let's also add the subtitle values and the pre-title values. There's pre-title. Everything is of type string. And let's bring it in. And let's also set a couple more. We have author. Okay, let's run it so that we can update our node. And there we see we now have the additional values that we need to set into Supabase. So back in Supabase node, now we can quickly grab the title from the previous node. And we also have the subtitle value, add that. Into the description field, we will set the second draft. And now let's bring in our author value. Same with the author photo URL. Now let's do the date. And then let's find our first draft and dump it into the first draft key. Same with the second draft. And then we also have final text to publish, and as a placeholder we will add the second draft there, so that if you then further edit this, or your user does, then that final text to publish can be automatically synced to Supabase and then updated inside the same field. Okay, let's do the post images array next. So make sure that we're setting the correct type. Our field in Supabase for this is an array, and we have an array inside of our n8n node that is the one previously. So then we're going to send in that array back to Supabase. Okay, let's keep going. Then we have image container. And for that, I'm going to use the image 6 landscape that is serving as our hero image. Okay, then also individually set the main landscape image value. And the same for the main square image. Then let's do our design tokens. The Supabase node in n8n is showing us that design tokens is undefined, but that is okay, and it is not undefined. That is simply how object type is recognized in Supabase and in n8n. Then grab the read time. And then let's bring in the template ID that we used. And then let's add the modifications object. Then we have the image prompts. Then let's find our rendered HTML key. There it is all the way at the top. Let's do our tags array. And you know what I think we'll do here? We initially defined our tags to be an array, but now we've all set it into a string. So instead of working with it as an array, we will actually go ahead and change the value in Supabase, or the column type, to be of type text string. And the way that we do that, when we come to Supabase and check out our table, we see that the tags is currently defined as an array of texts. So we'll edit the column, we'll leave the name as is, but we will uncheck define as array. And now this will accept a single simple string. Let's save it. And we'll actually also do the same for our keywords. So instead of expecting an array, we will set it so that it expects a single text type. Excellent. Let's keep going. So now we'll need to quickly refresh our node. Simply save up, step out of it, and the Supabase node will be automatically updated. So scroll back down. And now we can see that our tags has been changed to string here. Same with the keywords. And we can now set string values into these fields. Great. Same with the keywords. Perfect. Let's keep going. We also have an SEO underscore metadata field. And we'll go ahead and set the text key from the research compile tags and keywords from flowise agent. Okay, now let's create the array for the different platforms that we will be publishing this to. For now, we will make it simple and just hard code in these values. But typically in production, these would be coming from the UI or user selections. Okay, for our is published, the Boolean, we will open up our curlies and just type out false. And that is to define that this item obviously has not been published when it is first created. Same with is approved. We will say that it's false and that a user needs to approve this. And then we have our tool outputs. And this is where we can set all the different types of tool responses that were processed throughout the automation by the different agents that have tools provisioned to them. So one more time, we see here that we initially defined tool outputs to be of JSON object type. But we will actually go ahead and change that to text so that we can save strings into this column. Now let's do the same for the metadata. And now one more time, we need to refresh our node here. There we go. Now let's find some tool outputs to set into our tool outputs field. So let's define it as tools used plus data retrieved for assignment. And then I'll say something like data from agent 1. And we can grab the tool outputs here. And here we can convert it to JSON string. Then we'll do data from agent 2. For which we'll set JSON text from agent 2 and data from agent 3. Okay, let's do the metadata. Let's put the modifications into the metadata and convert this to string. Then we'll do the follow-up prompts, the design tokens, and let's see if this is all that we need. Okay, the Supabase node looks pretty good. Let's send it in. And there we go. Successful transaction has been processed into our database. And all of the different items that we created were sent in. And quickly refresh our Supabase page and see that we now have our first row that has been created in the Supabase table. You can check to see if all the values are there and if everything that was supposed to be set was indeed set correctly. All right, now that Supabase is all done, finally we are on our last node. This is the SendGrid node. We're going to use the resource of type mail. Operation is send. For the sender email, we will hard code in our core email that we use, but you can use whatever email is on your end. For the sender name, we will say something like Tesseract Assignment Delivery Team. And for the recipient email, that will actually come from the initial webhook node again, where we pass in all of the core details in regards to the assignment and the user that is sending it in. All right, now let's do our subject. So we'll dynamically construct this both from text that we pre-type out and values that we use. So we'll say your, and then I'll go into the webhook and find our assignment task type key. So in this case, it's social media post. And let's transform this so that it looks nice and readable for the user in their inbox. So we'll go dot replace all, and we'll open up single quotes, dash, and then we'll replace with nothing. Actually, no, I'm sorry. We'll replace with a space, and then we will convert that dot to title case. Now you could see our social media post looks like it should be part of a subject line. Okay, then let's type out titled, and now search for our title value. There it is. Drag it out. Great. Let's also type out is now ready for review and publishing. We will not be using a dynamic template, and our MIME type will be HTML. And then let's remove our placeholder value. Open up. And we're going to find our rendered HTML and set it here. So this will preview what we've created for the user directly in their inbox. No front end needed, no additional work. This is the same thing that we did with the HTML Online Viewer earlier. So we can quickly pop into that and check what is being sent. But otherwise, it looks like the HTML is correct. Excellent. SendGrid looks done. I'll go ahead and add one more field and set the reply to email. You can also add whatever email you normally use or the same one that you're sending from. And there we go. Maybe one more thing into the subject. Let's add the date and the time so that the user can immediately see when this specific assignment was finished. So I'll just drag in the date and also type out in all caps delivered. All right, let's send it in. Perfect. Our SendGrid node worked correctly. We can see that the message ID is in the response. And then if we check our inbox, we could see that indeed the assignment was sent to us as an email. Some additional formatting issues here, but nothing major. Most importantly, our automation is working. Great. So there we have our fully finished orchestrated automation. So now let's go ahead and run it. I'll speed up the tape here as to save time. And very nice. There it is. In 6 minutes and 3 seconds, we finish our full run. So now let's quickly go ahead and look at and review everything that we built today. So I'll zoom out a little bit. We started with a webhook node and we sent in a request which contained all sorts of assignment and user-specific data. We then sent this to the first agent, which did some research and provided us with the first draft of our copy. Next, we took the output from the first agent and sent this into an input of the second agent. This agent did additional research and wrote out the second draft. Then we converted these drafts into 8 image prompts using an OpenAI assistant. And then we hit 6 different visual models in order to generate our images. We used Flux, Ultra Realism, Minimax, Imagen, Recraft, High Drive, and GPT Image 1 from OpenAI. From OpenAI, we processed base64 data. We set that data in the set node. We also gave it a file name. And then we moved that data into a binary file. And then we sent that binary information to an AWS S3 bucket. Then we set the data again to create the perfect URL. Then we utilized a code node to parse the response. Then we set that data into another set node. Then we used Banner Bear to create different compiled images. We worked with the run node to give a small timeout in our workflow so that the Banner Bear nodes could finish. And then we used another agent to do tags and keywords research work for us. And then we parsed the response with custom code. And then we compiled all those assets into an HTML object. And then we used some additional custom code to convert new line characters. And then we did our final set of all of the generated data that has been created. We pushed that into a Supabase table. And finally, we have our items being generated and sent into our Supabase table. And from there, we used SendGrid to email the results to the user. All right, let's mark this as flow success. Thank you very much for watching, and I look forward to seeing you all soon.